In this video, we're going to look at some similarity ratios that can be found in right triangles. So to start off with, I'm just going to look at what those triangles are. I'm going to draw myself a nice little right triangle. I'm going to label, I'm going to mark it. It's a right triangle, I swear. I'm going to mark it with some vertices. Now, if we were to drop an altitude from our right angle there, B, down to the side, AC, we end up creating some more right triangles. And what's really cool about these right triangles is that they are all similar. So if we start out by looking at our original triangle, we had ABC. And I'm going to mark these sides, A, B, and C. Now, you'll notice that we also had some other triangles that were created. I'm going to add a D in there so we can go ahead and look at those triangles. Based on what we know about complementary angles, as well as using the third angle theorem, I can see that angle C is going to be the same as that little angle there formed at ABD. I also know that the measure at angle A is going to be the same as the measure of angle DBC. Now, by looking at it this way, I can go ahead and I can draw a couple more triangles that are also right triangles. So I already drew my original big triangle. I'm going to draw the other two. I'm going to start with the smaller one. So in this case, there's my right angle. The right angle occurred at point D. And then corresponding with C was point B, and then we had point A. So that's my other small one. Now let's do the medium-sized one. I'm going to draw that. And that medium-sized one had the right angle at D, included the angle C, and then it was up at B. So now if we are looking at these triangles, we can go ahead and we can label these sides as well. We already know that the distance from A to B is going to be A. I'm going to write that down. And I know that the distance from B to C is represented by B. And I know that the distance from A to C, which is not used again, is represented by C. So I think we're going to need to add in a couple of smaller things to help us write some ratios. So I'm going to split, because we split the bottom, into two parts, and I'm going to call those X and Y. And then that altitude is also the height, so I'm going to call that H. So I'm going to go ahead and finish labeling my triangles. A to D was represented by X, and D to B was that H. Now I had B to D, that was H, and I had D to C, which I called Y. So now that we have all of this labeled here, you can see that we have three triangles. And those three triangles are all similar triangles. I'm going to mark the angles again so you can see them. So there's that small angle. And this was that medium angle. So since we have similar angles, and we know that angle, angle, angle is for similarity, I can go ahead and I can write some ratios. I know, I'm going to get another color. I know that if I were to do A over B, that would be the same as saying X over H, which would be the same as saying H over Y. So you can see how I got these ratios from each of the three triangles. I can also find some other ratios using some of the other sides. Let's say I were to do C over A. That's the bottom over the other side. In the middle triangle, that would be A over X. In the third triangle, that would be B over H. Now there's one last set that I can look at. Let's see, I used A over B. I used C over A, so we're going to need to use B and C. So let's say we had B over C. If we're looking at our other triangles, that would be equivalent to H over A, which would be equivalent to y over b. We can use these ratios to help us find missing pieces in these right triangles, these similar right triangles. The relationship between these ratios can be expressed in another way, often referring back to geometric means. I do have a little bit about geometric means on the Canvas page, but to be honest with you, I use ratios more than anything else, and so I'm going to focus on using ratios throughout this video. Here we have an example of how the geometric means relate to the triangles in question. And if you want to look into this a little bit more, I suggest you pause the video. If not, I'm going to move on to some examples that require us to write some ratios and use those ratios and cross products in order to solve some problems. So here what I'm going to do is just refocus on those ratios, and we're going to go back and rewrite them and redraw them so you get really familiar with what we're looking at. The first thing I'm going to do is label all my sides so that I can actually write some ratios. So B, call this C, and C is splits between X and Y. I'm going to call it H. Alright, so now that I have all of those marked, I'm also going to mark some angles that I know that are in common. So I know that that angle down there at vertex Q is the same as that other little angle. And I know that the angle at R is the same as the one up near P. Now that I have my angles marked, it helps me, at least, I don't know about you, but it helps me see the triangles that we are going to be looking at. So I'm going to draw out all three of those triangles, and then I'm going to label them appropriately. I'm writing them in the same orientation because that helps me see how they relate to each other. So my first triangle I'm going to have be the big triangle. And the next triangle I'm going to have is going to be the smallest triangle. And the third triangle is going to be that medium-sized triangle where we have Q over here, and S is the right angle, and then P. So we also want to make sure that we label the sides correctly. So I have A, B, and C on this one. And I have X, A, and H on that one. And I have H, Y, and B on this one. So basically we can start out with a couple of different things. Let's figure out what our similar triangles actually are. So I know that I have triangle RPQ, and I can say that that is similar to triangle RSP, which is similar to triangle PSQ. Now you'll notice that those corresponding angles are in the same places. If you were to switch the order up, you would need to switch the order up for all of them. And again, I'm going to write out my ratios since we're thinking about those. I'm going to do them a little bit differently than before, but what's really cool is that it doesn't matter as long as you're consistent in your problem. So I have A and C. That's what I'm going to start with. A over C, same as X over A, which in that third triangle is the same as H over B. Then let's look at another pair. Now let's look at A and B. I have A over B, so that's the same as X over H, which is the same as H over Y. And then I'm going to look at my third pair. I haven't used B and C together, so I'm going to do B and C. And that is going to get me B over C is similar to H over A, or equal to H over A, which is equal to Y over B. So in these similar triangles, these are the ratios that I can use. More often than not, what you're going to want to do is look for ratios that have things in common. So from that first pair, I noticed that these two have an A. Probably going to use that ratio more than anything else. In the next one, I can see that both these two have an H, so I'll probably use that ratio for these triangles. And in the last one, I'll use the two that have the B. Now, this all relates back to that slide that I showed you on the geometric means. This is where those geometric means come from when we look at the cross products that are created when we use these ratios. Alright, so here we have a problem and we're missing some variables. We don't know what x equals, we don't know what y equals, we don't know what z equals. So that's what we're going to do, try to find. And you can see that we have a right triangle, and we are going to use the similar right triangles to help us find those different things. Now to start off with, I'm going to go ahead and I'm going to split my triangle into the 3 different parts, and I'm going to label them appropriately so I make sure that I can set up my ratios correctly. What's really helpful in this case is to go ahead and mark angles that are the same, because you're going to want to be thinking about that when you're drawing your triangles. So I'm going to mark this angle and that angle. I'm going to mark this angle and that angle. And we already know that the right angles are the same. So I'm going to start off with drawing my 3 separate triangles and labeling them. I'm going to start with the big one. That is an x here, a z here, and 10, because 6 plus 4 is 10, up top. Then I have another one. I'm going to do the smallest triangle. Now you want to make sure that you're keeping the things in the correct order. This is going to be z. And since this was the red angle, then that tells me that this side is going to be y. And since that's the blue angle and the blue angle, that means that that last side is going to be 4. And now my medium triangle. Again, I'm going to mark my angles to help me remember that. So this is my medium triangle, and that medium triangle had x along the hypotenuse. And it had 6 here with the red angle, and it had y there with the blue angle. So now that I have my 3 triangles all separated, I can go ahead and use it to find x. So in y and z. If I'm looking at this, I see that x shows up in the first triangle and the last triangle, so that's what I'm going to use. From the first triangle, I can see that 10 over x is the same as x over 6. Using cross products, I get x times x, which is x squared, equals 10 times 6, which is 60. So now I can take the square root of that, and I get x equals the square root of 60, which can be simplified to 2 square root of 15, or if you're wanting the decimal approximation, you're going to get 7.75. Alright, let's look at another one. Let's go ahead and find y. See that y shows up in that smallest one and the medium one, so I'm going to use that. I know that, I'm going to use the ones with numbers, so I know that y over 4 is the same as 6 over y. I have my similarity ratios. So when I use my cross products and set them equal to each other, I end up with y times y, which is y squared, equals 24. Take the square root, and we're going to end up with y equals the square root of 24. That too can be simplified a little bit. We can take out the 4, so we end up with 2 square root of 6, which has a decimal approximation of 4.90. Alright, last but not least, we have z. Z shows up in the first one and the small middle one. And again, I'm going to choose ratios that have numbers in them. So I'm going to start out with 10 over z. And its equivalent ratio in the other similar triangle is going to be z over 4. When I use my cross products, set them equal to each other, I get z times z, which is z squared, and 10 times 4, which is 40. Take the square root, and you're going to get z equals the square root of 40. Again, we can simplify this a little bit by taking out the 4. We can say that z is 2 times the square root of 10, or the decimal approximation of 6.32. So all we were doing was identifying those similar right triangles and then using our knowledge about similarity ratios in order to solve for the missing values. So here's another right triangle that's been divided into similar triangles. And again, we're going to try to find x, y, and z. And again, I'm going to mark up my triangles and draw them out as 3 separate triangles because that really helps me visualize what's going on. And I'm going to mark my angles so I can make sure I label everything correctly. Alright, so let's draw our 3 separate triangles. I always start out with the big one, and then the small one, and then the medium one. And I really don't care how you do it, but whatever makes you happy. Mark my angles. And then, of course, that right angle is up top for these ones. Alright, so let's go ahead and start labeling. If we're starting with the big one, I know that this side is z, I know that this side is y, and I know that this side is x plus 20. Then when we go over to the smallest triangle, I know that across from the right angle is z, with the red angle is x, and then we have the 10. If we go to our medium triangle, we know that across from the right angle is y, with the red angle is 10, and then that third side is 20. So now we can go ahead and set up some ratios in order to solve. The tricky part with this one, though, is that we're going to have to find a value, we're going to have to find x before we can do anything else. If you look at this first triangle, it has variables on all the sides. So, sorry, we're not going to have to find x, we're going to have to find a variable before we can finalize everything. So if I am looking at the second 2 triangles, I can write some ratios here to help me at least set them up in terms of each other. So let's go ahead and let's look at, I can do x over 10 is equal to 10 over 20. Okay. So that means that 20x equals 100. So x equals 5. Aha. So now I'm going back to that first triangle and I say, oh, x plus 20 is that side? No. We're crossing that out and we're writing 25 because now we know what x is. So now we can go ahead and we can find our other variables. I'm going to start out by looking for y because that's the next in line. So I see that there's a y, there's a y. Let's use these two. We know that y over 25, because we figured out what x was, equals 20 over y. So we are going to go ahead and use cross products, and that is going to get us y squared equals 25 times 20, which is 500. Take the square root of both sides, and you get y equals the square root of 500, which can be simplified a little bit. That can be simplified to 10 root 5, or the decimal approximation of 23.36. Alright, now let's go ahead and look for our z, and then we will be all done. I'm looking that I have z in the first triangle and the middle triangle. So I know that z over 25 is equal to x over z. So I know that z squared is equal to 25x. However, we know that x is 5, so we can replace that with a 5. And we can say that z squared equals 125. What this tells me is that z equals the square root of 125, which can be simplified just a little bit by pulling out the 25. And we get 5 times the square root of 5, or the decimal approximation of 11.18. That one was a little trickier, but again, we were just setting up our ratios and solving. In that case, we had to be careful to make sure we solved for x so that we could find those other values. Alright, next example. This one's a little kind of weirder because everything's a little skewed, but we can go ahead and do this the exact same way. First thing I'm going to do is mark all my angles so that I can make sure that I am drawing out my 3 separate triangles in the correct order and labeling them correctly. So I'm just going to draw them the same orientation that it was in the beginning. It doesn't really matter what orientation you use as long as you can label things correctly. I'm going to mark my angles. This is the blue angle. This is the red angle. And then we can go ahead and label things so that we can do our job of finding x, y, and z. So the first one was the giant triangle, so that would be 12, z, and x plus 4. Then I'm going to look at the smaller triangle, and that is going to have the hypotenuse of 12. This side is y. The shortest side is 4. And then the medium triangle is going to have a y, and it's going to have an x, and then the hypotenuse is z. Alright, so we have to determine our x, y, and z, and we're going to have to determine what is the best way, what is the best course of action in this case to go about solving these. What order do you want to do them in? I'm going to start out by kind of focusing on that middle triangle because I see that I could set up a ratio with just numbers, and that might be handy for me. So if I'm looking at the first triangle, I know that x plus 4 over 12 is equal to 12 over 4. So when I use my cross products to set them equal to each other, I have 4 times x plus 4 equals 144, which means that 4x plus 16 equals 144. Do a little bit more algebra by subtracting 16 from both sides, and you will have to do 144 minus 16, which is 128, and divide both sides by 4, and you should have the value of x. So we can say that x equals 32. I'll add that up here. Now to help me out a little bit, I'm going to go into all my triangles, and I'm going to replace the x with a 32. 32 plus 4 is 36. So now this helps me a little bit. I can go ahead and solve for my other variables. It doesn't really matter which one you choose to do next. If we were to do, let's do z. I see that 36 over z from the first triangle is the same as z over 32 from the second triangle. So if we are going to apply our cross products equal to each other, we end up with z squared equals 32 times 36, which is going to be 1,152. Take the square root, and we get z equals the square root of 1,152, which can be simplified a little bit to be 24 times the square root of 2, or the decimal approximation of 33.94. Now, if we want to find y, looks like y only shows up in those last two triangles, so I'm going to set up my ratios of 4 over y equals y over 32. Set our cross products equal to each other. We're going to end up with y squared equals 4 times 32, which is 128. So y equals the square root of 128, which can also be simplified a little bit to be 8 because of the 64 times the square root of 2, which is the approximation of 11.31. That one was kind of tricky. We had to kind of look at that and go, okay, well, what can I extrapolate first? You want to start looking for patterns and things that are going to help you find that answer more quickly. Like I looked for, oh, I can make a ratio with just numbers. That's always a good thing. Alright, I wanted to do one more just to make sure we were all good. Again, we're going to find x, y, and z. And again, I'm going to start out with going, okay, I have 3 triangles here, but they're all squashed together, so I'm going to split them up. This one's a little tricky because the angles all look kind of similar to each other, so I'm going to make sure that I mark them. Let's see, if we're going to have this one as the blue one, that means this one's going to be the blue one. And if this one's the red one, that means this one's the red one. Because they have to add up, they have to be complementary to each other. Alright, so I'm going to draw all of my triangles in the same orientation. Doesn't really matter what size you're drawing them as long as you're labeling them correctly. I'm going to put my blue angle down here, the right angle on the left. So now let's go ahead and label. The first one is the big one for me, so I'm going to label it as y, z, and 70, because 30 plus 40 is 70. Then I'm going to go to the smaller one, or usually I call it the one on the left. And for me, the hypotenuse is y, the red angle is 30, and the one with the blue angle is x. And then the next one, the last one I need, has the hypotenuse as z. It has 40, and it has x. So now I have everything all set up to go. I can go ahead and I can set up some ratios and solve. I'm going to start with x, and I see that x is in those last two triangles. So I'm going to look at 30 over x as the ratio. You could use x over 30. That'll just change what you set it equal to. You're going to get the same value. So I know that 30 over x is equal to x over 40 by similarity ratios. So we can go ahead and use our cross products equal to each other. We get x squared equals 30 times 40, which is 1200. Take the square root of both sides. You get x equals the square root of 1200, which can be simplified a little bit to be 20 square root of 3, or decimal approximation, which is 34.64. Alright, moving on to the next one. Let's go ahead and look at y. See, the y shows up in the first triangle and the middle triangle. Again, I'm not going to use y over z. Why would I do that? I don't know z yet. I'm going to use y over 70. Which means I have to use the same two sides in the middle triangle, which is going to be 30 over y. Going to multiply and get y squared equals 2,100. So y equals the square root of 2,100, which can be simplified a little bit because of this 100. You can get 10 times the square root of 21, which is approximately 45.83. And last but not least, we have to find z. So we have to use the first triangle and the last triangle. Use z over 70. And then that would be 40 over z in the third triangle. So we end up with z squared equals 40 times 70, which is 2,800. Take the square root of both sides, so you get z equals the square root, 2,800. And we can simplify that a little bit. We can pull out the 400. We end up with 20 times the square root of 7, or decimal approximation of 52.92. Yay, that was it. We were done. So I know that I went through all of those examples very, 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 very quickly, so I just wanted to recap. When we're drawing that altitude down the right triangle, we end up with three similar triangles. So if this was our right triangle, we were to draw that altitude. Those three triangles are similar to each other, and we know this because of the relationship between the angles. It has to deal with that third angle theorem and the definition of complementary angles. When we have this situation, the most important thing to do is make sure you identify the three similar triangles and mark them up. Where are the angles that they have in common? What are the sides that they have in common? I like to draw out three different triangles. I'm going to even write that. Draw them. So that you go ahead and you can see the parts that go together, where those similar pieces are. Then you can use those similar pieces to write your similarity ratios. Remember that there are 3 in all the triangles, but you only need 2 to solve. Generally, you're going to have something where 2 of them are going to match up, and you're going to end up with a variable squared. Then you can use your cross products, set them equal to each other, and solve. You're always going to have to take the square root. Well, not always, but a lot of the time you're going to have to take the square root. So you want to keep that in mind when you're simplifying. And that is similar right triangles within bigger right triangles.